Welcome to my channel Teach Me Physics by Nita Das. In our study of motion, it is important to be able to convert between different units. Whenever we perform calculations to calculate velocity, displacement, and time, the units need to be consistent throughout. It is therefore good practice to convert all measurements to SI units. For velocity, the SI unit is meter per second. For distance is meters. And displacement also SI unit is meters. A common conversion that will require in motion questions in between is between kilometer per hour and a meter per second. And we need to convert how to convert kilometer per hour to meter per second. Let us see an example like 72 kilometer per hour. How to convert? So in order to convert into meters per second, 72 kilometers. In order to convert kilometers to meters, we have to multiply it with 1000. And hour to second, that is we have to divide per hour. So hour is coming in the denominator. So denominator hour should be converted to seconds. So dividing by 60, it will be converted to minutes. Again, one more 60. Now it is in seconds. So this 1000 divided by 60 into 60 is a common factor that you have to use for converting any value to meter per second. Any value in kilometer per hour to meter per second. So this is like 7. We can write it as 72 times 1000 divided by 3600, which is equal to 72 divided by, this is 5 by 18. This is equal to 5 by, if you simplify this fraction, it becomes 5 by 18. It's always required to multiply any kilometer per hour. In order to convert it into meter per second, you have to multiply it with 5 by 18. So it is equal to 20 meter per second. So 72 kilometer per hour is equal to 20 meter per second. Describing motion. Motion examines how objects navigate and interact with space around them. Motion can sometimes be more counterintuitive than it might appear. While we have some existing vocabulary for motion, they are speed, distance, time, etc. In this lesson, we will establish a formal language for describing movement of all kinds. We look at the foundations of scalar and vector quantities, and we will begin to explore key terms like displacement, velocity, and acceleration. Scalars and vectors. So, scalars are measurements that have only magnitude. Whereas vectors have both magnitude and direction. Vectors are measurements So we are familiar with what is scalar. Scalar means it is having only magnitude. For example, distance. Distance we measure as like we will say 5 kilometers, 10 kilometers, etc. without saying any direction. So magnitude means just a numerical value is enough for describing the quantity. So distance is an example for a scalar. And displacement is an example for a vector because for displacement we need to say both magnitude and direction, like 5 kilometers due east or towards north, and likewise any direction we can say. Distance and displacement. Distance is represented using the alphabet small d, and it is the total length of a path that an object travels. The SI unit for distance is meters, or a small m is the symbol for meters. Displacement, and it is described like the change in position of an object from one point in time to another. Here the symbol used for displacement is capital S. There is an important note here. Both distance and displacement looks alike, but they are not the same. Magnitude of displacement is not always equal to distance. Distance means the actual path traveled by an object during its journey, whereas displacement is the shortest distance between two locations. For example, A and B, two locations are here. The actual path traversed by an object in order to reach from A to B is this, and this is referred as the distance, which is the path length. In this case, maybe like 20 kilometers. And the shortest distance or the shortest separation between the two A and B is termed as displacement. Here, displacement is given by this straight line which cannot be like we can say that it is not always equal to distance. In this case, it is lower than that of distance. For example, it may be 10 kilometers. To understand the difference between distance and displacement, consider someone swimming 3 laps of a 50-meter pool, starting from the end P, and he is ending at here Q. So each lap is 50 meters. So the distance traveled is, we can understand that each lap is 50 meters. So the total distance traveled by him is, distance traveled is 50. First lap, again say 50, again 50. So it is 50 plus 50 plus 50, which is 150 meters. But he is actually reaching, even though he is taking 3 laps, he is actually, the final position and the initial positions are at P and Q, which is only 50 meters. So the magnitude of displacement, however, is 50 meters, since the final point is 50 meters from the start point. So displacement is just 50 meters. Hope you understood the difference between distance and displacement. Speed is a scalar that measures how the distance changes per time. And speed is given by the equation distance over time. It is a scalar quantity. The SI unit of speed is meter per second. In our vocabulary of describing motion, it will be important to define speed as a term for how fast something is moving. And speed is the rate of change of distance per time, which is a scalar quantity. Velocity, again, is a second vocabulary associated with the kinematics. Here, velocity, again, is a vector quantity which measures how displacement changes with time. We can write it in an equation. Velocity is equal to displacement over time, and the SI unit of velocity is also meter per second. In case of an object that is moving with a non-uniform velocity, that means the velocity is not a uniform value, it changes with time. We need to calculate the average velocity, and it is using a formula. And the formula can be understood by writing it here. Average velocity, V average, is equal to change in displacement over change in time. That is, change is represented by the symbol delta. Delta displacement is the symbol for, S is the displacement symbol, and T is the time symbol, and the delta is the symbol for change in time. So any change we can represent as a difference between the final minus the initial, final and the initial. So the S2 is the final displacement, S1 is the initial one, and T2 is the final time, and T1 is the initial time, which represents the changes, corresponding changes. And V average again is measured, because even though it represents the changes, the units are for displacement is meters, for time is seconds. So unit for V average or average velocity is meter per second.